Welcome to our online class. Our topic for today is cells and symbol circuit, also referred to as electricity current 1. Remember, electricity is one of the branch of physics. We are going to entail part 1 of electricity as electricity current 1. Therefore, electrical energy has many uses, can be converted into other useful forms, e.g., light energy, heat energy, and operating other devices in our homes and in offices. Remember, in our homes, various appliances that we use, they require electrical energy, e.g., radio, television, laptops, and many others. Even the bulbs that we are using in our homes require electrical energy. That's the reason why we entail more in electrical energy in terms of electric current. Therefore, what is this referred to as electrical current? Electrical current refers to the rate of flow of charge. The flow also, we can say the flow of charge per unit time. Remember, when you say the rate of flow of charge, you cannot repeat per unit time because the term rate, it includes what we call the time. The SI unit from introduction branches of physics, we looked about the SI unit of electric current, where we said the electric current is the SI unit is amperes. From definition above, we have said that current is the flow of charge. Therefore, if with the flow of charge, we take charge divided by time. Therefore, current is equal to charge all over T. Therefore, if we move back a bit, if we make charge to be the subject, therefore we can say that charge is equal to IT, current times time. Remember time, when we were looking about the fundamental quantity, one of it is time. The SI unit time is second. Therefore, when you go to the calculation, all the quantity must be expressed in their SI unit. Example, calculate the amount of current. Calculate the amount of current flowing through a bulb if 306 coulombs of charge flows through it in 3.5 minutes. We say that current is equal to Q all over T, where Q is equal to charge. Our charge we have been given is 360 coulombs. Divided by our time we have here is 3.5 minutes, changing seconds because the SI unit of time is seconds. Therefore, our answer becomes 1.714 amperes. Types of electric current. Electric current is been divided into two categories. Number 1 is direct current. Number 2 is alternating current, AC and DC. What is this electric current? Direct current, it flows in one direction only, but alternating current, it reverses the direction with a given frequency. The direct current is the one that we use of the cells, what we call in our torches, in our watches. We normally use a current which is DC produced by the cells that we use. Alternating current, example of alternating current is the one supplied in Kenya using the Kenya Power, is an example of alternating current. So we move to simple electric circuit. A simple electric circuit, it consists of 4 parts. Let me say 4 parts, where we have a cell, we have a bulb, we have connecting wires. 3 parts. Generally 3 parts. Therefore, here we have a cell, we have a bulb, and we have connecting wires. We move from that part, we move to NB. What you are supposed to note is that a circuit that allows charge to move in a complete path when the switch is crossed is said to be a closed circuit. A circuit that does not allow charges to move in a complete path is referred to as an open circuit or broken circuit. Open circuit can also be as a result of loose connection of wires. For clarity and the neatness of drawing, symbols are used in representing an electrical circuit. What are some of these symbols that are being used? Therefore, directional of flow of electric current. We must know the direction of the flow of the current. So, convectionally, the flow of current is from the positive terminal to the negative terminal of a cell. It is opposite to the direction of the electron. Electrons move from negative to the positive. The instrument for measuring electric current is called an ammeter, while the one used to measure while electric current flow is controlled by an instrument referred to as a variable resistor. Therefore, we say that for clarity, for the neatness and the clarity, we normally use the symbols. For this case, the table below illustrates some of the symbols used in physics for the purpose of drawing, for the purpose of the neatness and the clarity instead of drawing the actual. For example, a cell is represented by a symbol which is like this one. Battery is represented by this one. Switch is represented by this one. A bulb or filament lamp is represented by either the first one or the second one. Wire crossing with no connection is represented by this one. Wire crossing with connection represented by this one. A fixed resistor is represented by this one. Potential divider is represented by this one. A fuse is represented by that one. Capacitor is represented by that one. Resistor, the same. Ammeter, that one. Voltmeter, that one. Galvanometer, that one. The way they are in the diagram. We move to electromotive EMF and the potential difference. What are the difference between EMF and the potential difference? Electromotive force refers to the voltage across the terminals of a battery in an open circuit. Also, we can say refers to the voltage across the terminal of the battery when no current flow in the circuit. Potential difference refers to voltage across the terminal of a battery in a cross circuit or when the current is flowing in the circuit. Potential difference and EMF are measured in terms of volts by instrument called voltmeter. A voltmeter is always connected in parallel or across the cell. The difference between potential difference and EMF is known as the Rost voltage. EMF is equal to BD, potential difference, plus to what we call the Rost voltage. In simple terms, Rost voltage can be given as EMF minus the BD, potential difference. This voltage is lost because of the opposition to the flow of charge within the cell, that is internal resistance. Internal resistance. Now we concentrate again on the part of connecting cells in series and parallel. Cells in series, two or more cells are connected such that the positive terminal of one is joined to the negative terminal of another one. Two or more cells are connected in series. They make up what we call a battery. NB. Connecting cells in series increases the EMF and the current in the circuit is higher. If you join, the more the cells in series, the more the EMF or the current in the circuit. For this time is at that point, we shall continue next part. Let us continue on the cells connected in parallel. Cells connected in parallel. Two or more cells are pressed side by side. The positive terminal joined together and the negative terminal also connected together. When cells are in parallel arrangement, their EMF is the same as the EMF of one cell. Current is supplied for a longer time in parallel connection of cells. E.g., here we have two cells. No, let's go back. Here we have two cells connected in parallel. You can see this is the first cell and this is the second cell. The positive terminal connected by a wire to positive terminal, negative to negative. This is referred to as a parallel connection. NB, cells should be arranged in parallel only when they have the same EMF. Otherwise, one will drain another. Now, also bulbs can be connected in parallel and connection. We have connection of bulbs in parallel and in series. Let's focus on bulbs in parallel. Each bulb functions independently. If one goes off, the other continue lighting. This is very effective when we are doing wiring in homes or in offices. This decreases the resistance of the current as many alternative routes or complete path through which to flow. A bulb in parallel have the same potential difference but different amount of current. E.g., our demonstration is here. This bulb is independent. This one is independent. This one is independent. This one is independent. Therefore, they are in parallel to one another because each bulb it has its own switch. Therefore, if one goes off, if one blows off, the others will continue functioning. That's one of the advantages of connecting bulbs in parallel. Bulbs in series. If one bulb goes off, others also go off. There is an increased resistance that the bulb might not be bright as those in parallel connection. Bulbs in series have the same current but different potential difference BD. So, like for example, this bulb is parallel to this one, sharing what we call one switch. Therefore, the current must pass in one bulb so that it can go to another. Therefore, if one goes off, it hinders the other also does not right. And B, bulbs in parallel are arrangement right brighter than those in series arrangement. This is the reason why the current in parallel is higher. The current in parallel arrangement is higher than in the current in parallel is because the resistance in parallel is lower than the resistance in series. An example, we have an electrician installed electric wiring in a house and connected the bulbs and the switches as shown below. So we have this switch 1 is going to control bulb 1, switch 2, bulb 2, switch 3, bulb 3. Hiya, let's look here, challenge ourselves. Explain what happens when the switch S1 is closed. If we switch S1, what is going to happen at this case? only bulb A is going to right because the current will move only to bulb A. Let's look at another essence. When the switch 2 is closed, if we switch 2, we started with switch 1, now we switch 2. What is going to happen if we switch 2? The current is going to move to bulb B1 and B2 only, but less brightness because of increasing resistance, because bulb 1 and bulb 2, they are in series. What if now we switch S3 crossed? All the 3 bulbs will light but with less brightness compared to in Roman 2 above. Reason? There is more resistance because the 3 bulbs, they are in series. Question number 2. Using redraw diagram shown for the best position of the bulb should be installed. Now we allow this one, you connect them in parallel so that it can work independently. Explain why you consider the arrangement in B above. Reason: when the bulbs are connected such that they are in parallel, the circuit resistance is significantly reduced and hence more current flow. The bulb lights with equal brightness since the operation voltage is the same. That's the reason it's encouraged when doing wiring, all bulbs should be connected in parallel, not in series. Anyway, materials whose electrical property falls between those of conductor and an insulator are referred to as semiconductors, e.g. silicon, germanium. Some liquid such as dilute sulfuric acid, sodium chloride solution, and potassium hydroxide conduct electricity. They are referred to as electrolytes. Thank you for the reasoning for this class.